Dear students, in today's class we are going to discuss two important topics. One is about the conservation of charge. We know that what is charge? Charge is represented by Q1, Q2, Q3 as we did in the previous videos. The charge can be positive and negative, right? In today's class we will discuss that how the charges are conserved. Second topic is difference between charge and mass. Mass is something which is represented as m1, and we know that if we multiply mass with the gravity, it gives us weight. Let us start with the conservation of charges. The conservation of a charge is the property which says that the total charge on the isolated system always remain constant. Conservation of charge can be understood on the basis of the knowledge which you already have about the conservation of energy. That energy cannot be created, cannot be destroyed. It can be converted from one form to another form. Similarly, the charge cannot be created, cannot be destroyed, but it can be transferred from one body to another. Right? Here we have used the term isolated system. The isolated system means the system which is not connected to its surroundings. Suppose you have any system which has charge Q, and if it is an isolated system, then the charge on this system will remain Q as it is not interacting with any other body. Let us discuss the conservation of charges with the help of this figure. We consider a body A which has plus 7 coulomb charge and another body B which has plus 2 coulomb charge. Before interactions, the charges before interaction are the first body charge plus the second body charge, and the total charge is 9 coulomb. Now, if the bodies interact, then the first body acquires plus 6 charge, plus 6 coulomb charge. We are supposed to calculate the Q, that what will be the charge on the second body B. We write that 6C plus Q should be equal to 9 coulomb as per the law of the conservation of charges. So from here we calculated that Q is equal to 3 coulomb. So the net charge remains conserved. So charges can be created or destroyed in equal and unlike pairs only. It is very important to understand that what we mean by equal and unlike. Let us understand this thing with the help of two examples. One in which charge is created and another one in which charge is destroyed. The pair production. Pair production is a process in which two gamma photons interact with each other and result in the formation of one electron and one positron. So, what is the charge on electron? Charge on electron is -1. Right? And what is the charge on proton? The charge on proton is +1. So -1 and +1 are equal in amount, but they are unlike because one of them is positive and another one of them is negative. So these are equal and unlike charges which are created during the process of pair production. The second process is the annihilation process, in which initially you have electron and positron. So this is the positron, this is the electron. They are moving towards each other for the process of interaction. The process of annihilation takes place during which two photons are produced, right? So initially the system was having individual charges, but during the process the gamma photon is formed and net charge is turned out to be 0, right? So here again equal and unlike charges has been destroyed. Now in the next topic, let us compare the charge and the mass. You know that your Coulomb law says that the charges exert force by the expression this r square is the distance between q1 and q2. Then the gravitational force is given by this equation, where r square is the distance between the masses m1 and m2. Both the Coulomb's law and the gravitational forces obey the inverse square distance behavior. But the charges and the masses are not same. There are several things which are different in them. The first, the charges on the body can be positive and negative, right? But mass is always positive. Mass is always positive. Negative mass doesn't exist. There is no term like negative mass. The second thing, if you have a charge on somebody, if it is moving, charge will not change. Whether the object is moving or the object is stationary, the charge on that particular object will not change. But the mass of the body increases with its velocity. You know the relation m is equal to m naught, where m is the mass, m naught is the rest mass, divided by 1 minus v square by c square, where c is the velocity of the light and v is the velocity of moving body. So this thing is very clear that the charge on an object will not change, but the mass will change if there will be motion in the body. The third thing, we have done this equation Q is equal to NE. In the previous videos we have discussed this equation. This is quantization of charge. So the charge will be always integral multiple of charge on electron or the positron, but no such condition for mass. Mass can have any value. It is not required that the mass should be quantized. Mass can have any value. They can have integral values, they can have fractional values. There is no limitation for the value of mass. No fixed restriction is there. The next thing is that electric charges are conserved. Electric charges are conserved, but the mass can be converted into energy, and energy can be converted into mass by using the equation E is equal to m naught c square, right? Electric charges are conserved. They can be created or destroyed in pairs only, but mass can be transferred into energy and energy can be transferred into mass. The next important difference between the charges and the masses is that if you have like charges means either positive positive or the negative negative, they will repel each other. And if you have unlike charges means one charge is positive and another charge is negative, then they will attract each other. Means two type of forces are there. One is the repulsion force and another one is the attraction force. But mass always show force of attraction. Mass always show force of attraction. There is no force of repulsion. Next is that the charge cannot exist without mass. So charge is always carried by some object, some body which is charged, right? So if you have any object which is charged, definitely there will be mass of that object. So the charge cannot exist without mass. But there is no such condition for mass to exist. Means mass can exist without charge. So it is not necessary that if some object has mass, it must have charge also. This condition is not there. If you have any charge which is moving at high velocity, it will emit EM radiation, electromagnetic radiation. Moving charges emit some light from them, and those radiations are the electromagnetic radiations, in which electric and magnetic field are perpendicular to each other. On the other side, if you have accelerated mass, it emits no radiation. Whatever is the velocity at which your mass is moving, it will not emit any kind of radiation. The next difference is that charge has derived units from the expression which is current is equal to rate of change of charge per unit time. Then the units of charge are ampere second, where ampere are the units for current and seconds are the unit for time. So it has units ampere second, while your mass is the fundamental unit Fundamental units are those units which are not derived by any expression. So it has the units, the mass in SI system is measured in kg. Kindly share the videos, like and subscribe my channel. Thank you.